All right, getting ready to get started in 1 minute. Hi, everyone. Welcome to another great session of uh, discussing Fusion 360. My name is Jason Arms. I'm the president of FIRST RGV and RGV STEM. And we are joined today with Marco and Lucas from the Mission CISD Patriot Engineering team. And this is the third and final installment or episode in our exploration of Fusion 360. So please make sure you post any questions in the chat. And as we go through this today, you can you can raise your hand feature, or you can just type in your question in the chat, and we'll be happy to make sure that that question gets answered. So Lucas, go ahead and take it away for us.
All right, so let's go ahead and start looking at Fusion. I'm gonna go ahead and share my screen, open up Fusion. Perfect. All right. So what we're becoming today is looking at 3D parts. So we want to look at how to create three-dimensional objects and stuff, and we also want to look at modifying 3D objects. And I have Marco here willing to help me out with all this. And so we're going to work side by side. We're going to see if we can cover all these topics. So like I said, there's two topics. One is working on creating 3D models, and the second is to modify 3D models. So there's these two tabs on the left side, which we've never covered, but we're going to cover them now. We have these tabs here. We're going to focus on the left two tabs. We have create, we have modify. So there's a ton of different options you can use, but quite frankly, I only use maybe 4 normally out of this entire list, and I maybe use 3 out of this entire list. So it's quite, it's very versatile functions, but you only need very few normally. So let's go ahead and take at the most important one in my opinion, and that is extrude. So what extrude does is that you can make like a sketch, right? Like a shape of some kind, and you can pull it apart through an extrusion. Let's go ahead and try that out. What we first have to make is a sketch. So I'll click a plane. And if you guys are following along, this is the perfect time to go ahead and follow along. So what we can do is make a sketch. We can click this, for example, pull off to the side and click enter right there. And so now I have just a random square. I don't even know the dimensions on it. What I'm going to do is I'm going to click finish sketch. But now here on our last session, we covered sketches. But in this case, we're covering 3-dimensional sketches. So here's our sketch, and we want to do is convert from 2D to 3D. Now, how do we do that? Well, that's the entire point of CAD. All CAD you're doing here is essentially just getting a 2-dimensional object and transferring it to a 3-dimensional object. Let's go ahead and extrude this. I'm going to click extrude, click the face, and notice if I pull it off to the side, I automatically have a 3-dimensional model. So Marco, go ahead and walk me through all these different options I have on the right side.
All right, so we have this tab that comes out on the right side, and as of right now, he has profile selected, meaning that the current face that he has selected, or the sketch, is what's highlighted in blue. And what he has currently is profile plane. profile plane basically extrudes the sketch. Can you click it for me, Lucas? It'll exclude, huh?
Go.
It'll extrude the sketch that you're currently on. Offset plane means that you can offset it, and then from there on, you can extrude it. He will put in a certain amount of millimeters. I don't know.
Yeah.
And then the last one is from object. So he can extrude it from the object, or you can extrude it from a different object, depending on where you're trying to extrude it from.
Yeah, right. So what we want to do in this case is go from a profile plane. And so we picked out our profile, we picked the sketch that we want to extrude from, we pull it out. And the next thing is, Marco, what are these here?
The direction basically the one-sided direction is where you extrude it from. You can do a two-sided, so not only will you extrude it on one side, but it'll do it on the other side of that plane. And the last one is, I think, symmetrical. It'll do it like this. This is the same thing, so it'll do it with it'll do it in sync. The two-sided, you can pull one side and you can pull the other side depending on how much you want. And one-sided, you only pull it one way.
Exactly. And then distance and taper are just, well, obviously distance and taper is just, it kind of shrinks itself. For example, we'll try something out. We'll try maybe like 10 degrees. And you'll notice how it kind of just changes its shape. Go ahead and look at this. And it tapered itself by 10 degrees. So let's go and put that at 0. Now, this thing it's really, really critical to understand. Not about extrusion, but about fusion by itself. And it shows up right here. So for those of you that are watching, this is incredibly important. And I highly recommend you learn this. So Marco, explain to me what these here do, these 5 different functions.
So new body is going to create a whole new component. And but that component is going to be static, meaning that you cannot move it around. Join is going to build off of an object that you have already created. Cut is going to cut out whatever you've made through that object. Like I explained, new body. And then new component is you can make a whole new sketch, you can extrude it, and you can move that around depending on where you want it.
Okay, yeah, so sorry about that. So we're gonna do is extrude. And so like I said, we'll extrude this out, for example, and pull it out. So the question becomes, well, what kind of shapes can you do? Well, I can tell you what shapes you can't do. And I'll show you, it's a very interesting question. So like, let's just say we go ahead and delete everything we have here. But let's make a rectangle in which all the points do not close. I'll show you what I mean by that. Let's just say I have a rectangle here. And I have these points, but it doesn't close all the way. So notice right here, there's still a gap right there. So if I have that gap open, can I extrude this part? Well, the answer is no, because there's no profile to click. You see it says profile? A profile is you have any sketch that's completely enclosed. So it's completely closed on all different sides. That's a profile. And that's what a sketch is. So try maybe a circle. Okay? And if we get a circle and extrude that, we would get a cylinder. So you pull it out, you pull it and extrude it, pull it out. And you can see this other bar in here. And if I pull it like that other bar, it tapers. So you can both pull it out and taper it. It's a very interesting function. And yeah, so see, if we have new body, for example, if we click new body, I'll put this back to 0 for the sake of example. So here at 0, if I have a new body, it's not gonna be able to move around at all because a body is part of a component. It's not even able to move. But if I go ahead and see in the bottom left section, I can click it, right click it, and then click edit feature. If I change it to a component, oh, it doesn't give me the option. Hold on a second. I'm gonna go back, I'll extrude that. And if I pull it out, it'll give me the option to make it a component. Now look at this. If I click that and I click OK, you'll notice how I'm able to move it around. Now this is super useful because like I said, a body is essentially almost part of a component. See, if I was to add another shape onto that there, it would be a body. You have much different bodies can create essentially a component. Bodies can't move in time, so components are a lot more useful in my case, in my opinion. So that's that. Let's go ahead and look at the next thing. And like I said, you can make any sketch and just essentially just make it a extrusion. Any shape at all and pull it out. The question is, you don't always want something to be pulled. What if you want maybe like a ring? Well, what I would do for this is I'd say, I can make a shape. And I can tell it, here's an axis, and I want you to spin around this axis. Let me show you what I mean by that. There's my profile right there. And I'm going to make a line, and I'll put it right about maybe here, for example. I'm going to pull it down right about there. I'm going to click Finish Sketch. And it's something called the Revolve function on the left side here. I click Revolve, and I can click a face, which already has it clicked for me. And I can click the axis. So I can click it, and boom. There we go. So notice how it automatically revolves itself. And so I can maybe, if I don't want all that, I can pull it out to the side. If I want only 45 degrees, I can get 45. If I want 90, I can get 90. And it goes on and on. So it's a very useful tool in which we'll use this later on, for example. And yes, there's both different sides, like asymmetric, like we just covered earlier. And notice how it starts at one side and it moves out from both sides. And so there we go. That's that. And that's that for the revolve. And again, you can use any shape. So let's get something a little bit more interesting. Let's go ahead and get a box, maybe from there to there. We'll pull it up. Oh, let's try pulling that up a bit. No, I'm just kind of doing whatever at this point. I can get a spline. I can get any shape that I care for. So I'm gonna click that. And now that I'm gonna make this all one profile. So I'm gonna click Revolve. I'll click that, that, and that, and that. Then I can click the axis that I want to spin around. And there we go. Obviously, it's a little bit of a tight axis, but you can see that it creates a shape, right? And so I can change the shape of this revolve, not by editing its features, but by editing its sketch. And so that's what's really important about CAD is that you use two-dimensional sketches to create 3D objects. So all of our sessions that have been leading up to this here. And this is really important stuff because this is how you can create any model that you want. I click OK, and now here we have this interesting looking shape, and I didn't know it would look like this, but it's quite interesting. And if I want to change it, I can look at my sketch on the left, and I can edit the sketch. And if I pull that axis away, what's going to happen is that I increase my radius. And now you notice that this ring is much wider, it's much thicker now. So there you go. You change the sketch to change your model. Marco, do you have anything to add to Revolve?
Nope. I think you've covered it all.
I think so too. There's not that much. Oh yes, you can go by angle. To means a face. So instead of just saying going by angle, you can say I want to go to this face. You can get an accurate mark or full, just a full 360 degrees. Yeah, I think that's pretty much it for that. We can just finish the sketch, and I can just left here and I can delete the sketch. So the next topic we want to cover is now holes. Let me first get rid of this body now. Perfect. Okay, so we're starting fresh. Let's look at the next piece. And that is holes. Now for people in FTC, this is really important because a lot of things we have to deal with has to do with screws. So you screw things together and a hole is really important for screws. So let's go ahead and just create a shape, okay? Let's just create a random shape. I'll use it maybe a cube, right? Let's just get a rectangle and just extrude it. What I'm gonna do is get a cube and extrude that. So here we go. So I'm gonna pull it up, and there we go. And so there's our piece. Now what I wanna do is I wanna make a hole. Let's say I wanna screw that hole right where my cursor is. Now what I would do to do that is I'd make a hole. So I click this hole feature, and I can choose anywhere on this cube that I want. So I'm gonna click right here in the center. I click there, and Fusion automatically gives me a hole. Now notice, whenever anything's in red, that means it will cut itself. So it's gonna cut through. And so I can use this blue little dot to move the position of the hole. I can maybe use some dimensions to hold it in place, but you get the general idea. And this little bar here, when I pull it, it's gonna change the diameter of the hole. And when I change this bottom, notice it has a little point. I can pull it down and I can give it a greater length, or a depth would be a better word. So the question is, what if you don't want that shape? What if you want just a flat out hole? Well, you have all these different types on the right side. So it says hole type and hole tap type and drill point. These are all different types of holes you can use. So for example, I'll click the counterbore and notice how the shape at the top of my hole changes. So look at this. It's quite interesting. So it's going to change the actual shape, and you can even increase the length of it. And so this would be, in terms of FTC, maybe you put your screw down there and you can make your screw flush with your part. And what we're covering here is really useful, assuming you have access to a 3D printer or any kind of machinery. It's useful. You can still, it's very useful for creating with custom parts, even if you don't have access to these machines. Maybe even preparations or thought planning. It's still really useful stuff to know. You look at a countersink and notice how it has almost like a little bend, in which we can get to later on. But notice there's a little tip there. I don't want that tip anymore. How do I get rid of that? What I can do is I can go to drill point and click flat. Now that I click that, it's flat. And the last thing we can cover here is the hole tap type. So in this case, it can give you almost, in some cases, it gives you even threads. So for example, we'll go up to here. This is tapped. Pull it out. Oh, wow. And so notice how it taps a hole for you. And this is useful for maybe CNC machines or something. We can look at this here, and this is a hole. This is, what is this? Taper tapped. And so notice how I can change the position of it. I can change the length of it. It's very useful stuff. Now, last thing we can cover is this here. So whatever type you give it, and whatever I click on, it will automatically change. So instead of maybe pulling it around, because sometimes it's not that accurate. What if you want, instead of 60, what if you want 59.9999 or something? What you can do is you can access these numbers here and change everything specifically. Very useful stuff. So yeah, Marco, am I missing anything?
You forgot to placement.
Oh, that's right. That's right. Okay, so in this case, what I can do is, I think I need to have like a couple of sketches for that there. It's not going to work right now, but the idea is instead of having one hole, you can have a grid of holes. That's useful. Let's just say you're trying to model a part from GoBuilder. It's this grid of holes all along. You can model that using the placement. So yeah. You have all these different options here. I've, to be honest, never had to use them before. Let's just make a hole there, for example. Let's just make it the most simplistic hole that there is. And so let's see, we can try maybe a taper hole. Okay, here we go. And so it gives us these different thread types. So we can check all these different thread types, and it's useful for like standard stuff. You can get standardized material based off of this. So notice that when I change these, I can now get a pre-made thread. This depends only if you know what kind of thread you're using. I know for GoBuilder, they use an M4 screw. For Rev, they use an M3 screw. And you can access these different threading types. And well, that's not threading types, but those are sizes, but the idea is the same. You can access the different types of threads and stuff. Sizes, designations, all of that. So a very useful tool. So the question is that like, we can also, just in case you're wondering, you can create holes without the hole function. So how would you do that? Well, what I would do is I would pick the spot that I wanted. I would make a circle and extrude into the cube. Let me show what I mean by that. So I'd click this plane here, and I would make a circle. Let's just say we're dealing with a GoBuilder screw, so I would give about 3.7 millimeters, just in case for tolerances. And so there is my screw hole. Now I'm going to finish sketch. So what I want to do is I want to push it and create a hole down into the cube. So I would extrude that face, that profile, and pull it down. Now notice, this is really interesting. You can actually get the same color as before. Remember, it was a bright red, still a bright red. And what it's doing is that when it says, whenever something's a bright red, that means it's cutting. So here on the right side, you see it says cut. We're accessing the cut side. So very useful stuff. You're just cutting straight into the part. And yeah, if I create, this is interesting. If I create a new component, what's going to happen? Well, if I click that, I should be able to pull, let me see, but I should be able to pull this part out. Now, however, if it was a body, if I made a body, it would have been directly attached inside of that cube. It would have been associated with that cube. Okay, so actually it's an interesting question. So if we were to try that, if we were to have instead a sketch that, oh yeah, look this up. I can click this. I can right click my sketch and I can click an extrude. And so automatically it's going to extrude in that one sketch. It's just a convenient tool. Anyways, this is just a question of using a body. If I was to pull down and make a new body, for example, it's going to become one with the cube. And now no matter what I do, no matter what I pull it around, it's stuck. So how could I separate the two of them? What I would do is that I'd find what I wanted first, which was body 3, and I can right click it. I can right click it and I can click create components from bodies. So it just gets a body and converts to a component. Now watch this. If I get that newly created component, I can pull it out. So the thing you have to understand is that if you want to make a joint, if you want to manipulate something, it's very difficult to manipulate bodies because bodies are associated with the part and they're not moving, but components are. So components are a lot more versatile, but bodies have their place because they are one with the component or body. So yeah, interesting things. Let's go ahead and delete that body. Yes. And delete our newly created component. Bye-bye. And delete that as well. Okay. Let's go ahead and start fresh. Let's see. Did we cover most of these parts here? Okay, I think we covered enough. Let's look at modify. I'm going to bring back that cube that I just had. I'm going to click Control-Z a lot of times. All right, perfect. So here, I'm just going back in time. Perfect. So here's our newly made cube. And so what is I want to modify this. So a lot of times you run into the issues of that, like you can't really edit it in a sketch, but you can edit a 3D model. So how would you do that? Well, it's not that bad. Marco, explain to me what a fillet is.
A fillet is a tool used to round edges.
Yes, it's a fillet. I struggle with trying to get it. It's pronounced fillet, I believe. And wow, is it difficult for me to to use the word fillet, not fillet. All right. Let's go ahead and maybe add some more selections. And notice what's happening is that of my part. And if I don't click a line, let me click another line here. If I click all the lines of the part, maybe that side and that side. So if I click all the edges, now notice edges, not any part, but just edges. It rounds out edges. And you can use this bar to control exactly how far you want the edges to go in. And pull it in. Oh, that's too far. So notice this is an interesting example. Let me start from fresh. If we say maybe 10 for each one, yeah, there you go. Now it rounds out all the edges. So Marco, explain what's going on here.
Okay, so rolling ball is going to round the edges of the cube, or in this case, a rectangular prism. I think that's what it is. But there's rolling ball, and then there is, I think, consistent, or I don't know what it is. But rolling ball is going to round the edges, making the part smoother than having a sharp corner or sharp edge. In this case, people mostly use the rounding of the edges just to make it much nicer of a part, much easier to I don't know, much
Yeah,
easier.
no.
I don't know.
Yeah. So the idea is that you can get rounded edges using a fillet. So let's say we want only a few parts. I'm going to go ahead and maybe delete some of these, or we'll go ahead and delete some of these. We'll go ahead and cancel out. Let's try using the next thing, which is something called a chamfer. Now the chamfer does almost the opposite of a fillet. in which, if you can, it's actually pretty obvious what it does. It doesn't round it out. Instead, it makes like a, I don't know, like an angled cut in a sense. And so I can get different cuts in the shape of the cube. And so I can click maybe this, enter. And of course, this only is a 45-degree cut. What if you want maybe something a little bit more different, a different angle? So I can click that line, and I click the chamfer type, and I can click maybe distance and an angle. So I can say that wide, and I can change the actual angle of it. Now, of course, this has its place in use. Sometimes you don't need it, sometimes you do. So the next thing we can cover is what I think is honestly the most important. It is the press pull. So there's different types, but a press pull is actually pretty intuitive. You find a face, you click it, and you pull it. That's it. That's as simple as it gets. And what's really interesting about a press pull is that it's very versatile. So it doesn't work with just faces. It can work with more complex shapes. So let's go ahead and try something a little bit interesting. Let's create something a little more complex shapes. Let's go ahead and try making a sketch on this plane here. And I'm going to make a few actual shapes. And this is entirely for experimentation. I'll go ahead and pull out each of these. And so notice, there's different extrusions, and I'm joining. I'm not creating a body or component, I'm joining. When I join, it makes these three newly made cubes equal with this other original cube. I'll click OK. And so there we go. So we can try a fillet in this case. And so we can click this and we can pull it. Oops. We can click this and we can pull it. And there we go. Notice that. So it gets that one edge and it smooths it out. I can also try it again, but I can click an entire face. And so I can pull that out. And notice how it fillets almost every single line here. So when you click on a face, it changes and modifies and smooths out each edge that you clicked or that could be associated with it. So that's that. And now look at this. Now we have quite an interesting looking part. And of course you can, I should mention, you can modify. I'm going to right click the fillet, edit feature. And you can modify the actual distance. So when you can use the arrow like we just saw. And I believe this, oh no, that's for something else. Let me go ahead and get rid of that real quick. Let's try that again. So this, I'll edit the feature, and you can change the actual curvature of the fillet by actually changing the radius. Because what you're doing is that you're creating a smooth out circle in a sense. An arc would be a better word. And so if I make the radius smaller, you'll notice, oh, actually it's not gonna work. Let's try 50 maybe. So notice when I make it larger, it's changing the actual radius to make it a little bit more smoother. And you can change it also with the arrow as well. And notice how once it can't create a shape, for example, right here I have it at what, at 0? And Fusion, or actually let's try farther. Let's try over here. And so now I have a massive radius. And it's giving me an error. And it's saying that it's impossible to make that because it just physically won't work. Because you can't just have it, you see, because watch right when it gets to a certain extent, look at that. You can't, you can't go past that. It's almost like a maximum. But let's just click OK. So here we have an even more interesting shape. Let's try using something interesting, like the press pull. The press pull is something that you'll be using a lot, okay? So if you want to extend something, change something, we can press pull it. So I can click this face. Now notice, was this face here before? No, it wasn't. So if I click this face and I pull it, I'm not going to promise it's going to work. Maybe it will work. Is it going to work? I don't know. It's probably not because a little bit, there it is, it's working. So notice, probably should put in numbers instead. 100, see that? Look at that. You can see it's actually changing a bit. Now, of course, it's having difficulty with one of the fillets. I believe it's this cube here. And it's kind of breaking the fillets in a sense. But the idea is that you can use the press pull to modify almost any face and pull it or push it in. So the press pull, this button at the left here, is very versatile and very useful. Like for example, in this picture, you're getting that circumference, that diameter, and you're squishing it together. So let's go ahead and create our own, for example. I'm going to click maybe, we can't create, let's try 150 maybe. There we go. So there we go with that. let's go ahead and try something a little bit interesting. Let's practice what we just learned, a hole. Let's make our hole here. And let's go ahead and say our distance will be 2. It's going to end at the end of this face here. So we click that, we click OK. And I think all these are fine. I don't want it to have the little tip. I want it to be flat. I want it to be simple. Yeah, I think it's good enough. So I can click OK. So there's a hole. Honestly, this is an FTC training, and I have no idea what you use this for in FTC, but it's an interesting looking piece, and we're just using it to test out our parts. So let's go ahead and look at the next thing. So what we can do is we can use our fillet to maybe smooth out this line here. And I can pull that out, and there we go. There's our smooth out line. I can use maybe the other side, and we can test out a chamfer. Chamfer, where'd it go? Chamfer. So we can test out a chamfer. We click the edge, and then we can pull it. Oops, hold on. And we can pull it. And so notice, on one side, I have a chamfer, and it's thinking. Once I have a chamfer, on the other side, I have a fillet. And now the next question is, I said the press pull. The way we can implement this is we can actually maybe expand it or shrink it. Let's go to press pull. I can click this button here, and I can change the actual diameter. Notice when I pull it in, it shrinks. Right, notice the other side, it shrinks. But notice what's not changing. If you notice, the fillet is not changing, nor is the chamfer changing. All that's changing is the diameter. So this becomes a problem because what happens when you get too far out? If you go too far out, the chamfer ceases to exist because we give it a number or something, and it just exceeded this line here. It's even giving me error of that chamfer, right? But if I pull it out too far, see, it's gone. The chamfer is gone. And does the fillet still exist? My computer's freezing up. 1 second. I'll talk about it in the meantime. So the idea is that the press pull will work for certain things, but that's assuming it's not going to break something else. And so notice that Fusion gave me an error and reverted it back to normal to save myself from myself. I pull it out a bit, for example, and error again. Okay, maybe pull it in. Oh man. Okay, here we go. Let's click OK for now. That should be fine. Try maybe 100. That should be okay. 100. Oh, that's fine. So there we go. That's the idea of the press pull. For modify. Okay, so Marco, should we get into the interesting stuff, the stuff that we wanted to create?
Sure.
Or should we cover more into the features here?
I think you've covered a lot of it already. We should probably get into depth about the FTC.
Okay. So let me ask you a question. We have the parts of the playing field. So I had an interesting idea, and that is to create the playing field. For the sake of simplicity, I'm going to start a new design, start from scratch. And this is going to be super rough, okay? This is by no means like perfect, but this is just a rough, just a way to understand how to use the parts we just covered. So what we want to do is create the FTC playing field. Let's go ahead and open up a sketch, and we're going to do is create just the playing field first. Now the bottom we know is a 12 by 12 field. And so I'm going to click this rectangle, and I'm going to maybe click here. And I'm going to actually change it out to be specific. Now, notice how it's in millimeters. Fusion is an intelligent software, and I can actually plug in 12 FT, and it knows that I'm dealing with feet. And so notice how like the length automatically just becomes wildly larger. And I can do the same for this side. Click Tab and 12 FT, 12 feet. I click Enter, and there we go. We have a solid score that's 12 feet long, or 3,657 millimeters long. So what we want to do is apply the stuff that we just learned. So we're going to go ahead and we're going to extrude this. This is the floor of our playing field. Now, in reality, I'm not sure exactly how much it is. I'm going to guess about 1 inch, maybe. I think that's how thick the tiles are. So there we go. Now notice how this is not a playing field. This is sticking up in the air. We need to be a floor. So what I use is a move and copy button. I'm going to click this, and this allows me to edit. So this allows me to edit my piece. I'm going to click this entire body, and it's going to allow me to rotate it. So I'm going to go ahead and look at it from the side, and use these little angle buttons. So I can rotate it down about here, negative 90 degrees. And now it's a plane. It's on the floor, which is super useful. So the next thing we want to look at is making the walls. The way I would do that is I'm going to make a sketch. I'm going to click this plane. So notice this sketch is going to be directly attached onto the surface of the playing field. I'm going to open this square here, and I'm just going to make a random square. If you were here in our past sessions, we covered more in sketches. So I'm just going to assume you guys already know about sketches. What I'll do is that I'm going to just simply make a dimension from each one. Like I said, this is really rough. I'm just going to assume this is maybe 1 inch. And I'll assume that this is 1 inch as well. 1 inch. I'll assume this is 1 inch as well. Now what I'm doing is that I'm creating the walls. I'm creating the walls of the playing field. Okay, perfect. Now what I'm going to do is I need to now create the edges. So if I zoom in, I only created a sketch for the edge. So I'm going to click this edge here for the corner and make the entire edge of the playing field. Make sure I click it, zoom in, and boom. So now I have these two. Now notice what I just did is that I created a profile. I'm going to use this profile to extrude. So I'm going to go ahead and click the home button. Now I'm going to extrude this newly made profile. And we'll pull it up about maybe a good, how tall is the wall? About a good foot? Maybe I think it's about a foot. So pull it up about a foot tall. 1 FT, 1 foot. And we're not going to do is we're going to do maybe a new body, right? And so maybe later on is that I'm not using a joint. I'm using a new body. Not a new component, a new body. So the reason I'm doing this is because a joint would make the wall and the playing field one single piece. But if I do a new body, it'll make it 2 separate pieces, right? But a new component would make it also 2 separate pieces, but they could separate. But I don't want them to separate. A wall is attached to the playing field, but I want them to be 2 separate pieces. So here we go. Here's our new body. And notice how I cannot move it. See, it's stuck in place, which I know, that's how I know it's a new body, a body. So there's our playing field. Really rough sketch, but this is just the general idea of extrusion. So let's go ahead and take a look at something else now. What I want to do is I'm going to open a new sketch, and this here we have a whole launching game. So let's go ahead and create the rings. So what we want to do is say, there's 2 ways to do it. We can actually make a shape of a ring and extrude it out, or, well, we'll cover that for now. So we'll get a shape of the ring. We know that the inside is about 3 inches in inner diameter, and we know that the outer diameter is 5 inches. And so there's the beginning of our ring. Now, what I'm going to do is I'm going to click Finish Sketch. There's a ring. So you get the idea. I'm going to pull that. This is interesting. I can right-click it, and it's going to give me the option of extrude. So if you ever right-click something, it gives you a ton of different options. It's just there for convenience. All the buttons are already at the top, but they have it there for convenience. So notice how there's all these buttons at the top, but when I right-click it, it only gives me very few and selected options. This is another reason why Fusion is so smart, because it knows I want to extrude, which I do. So I extrude it, and I know that this is 0.75 inches in diameter. And there we go. But this isn't entirely an FTC ring. First of all, it's not yellow. And the second thing is that it's not rounded here at the edges. So how would we round that? Well, what I would do is I use a fillet. So I'm going to click here. Oh, I'm going to click here. I'm going to click a fillet. I'll click this edge. I'll click that edge. And I'll also click the inner edges as well. Now, I believe I could not find any dimensions on the fillet, but it's roughly, from what I found, about 0.2 inches.
0.25.
25, is that what we found? Okay, perfect. There we go. There is our FTC ring. And something that's not entirely important, but very useful, is it's not yellow. I don't want to make it yellow. What I can do is on the bottom here, you have physical material and you have appearance. So notice this little item it shows you is that with material, you can specify what kind of material this is. You can say if it's metal, it's plastic, all the different things. Right now, I just want to cover appearances. So this here is roughly like, I mean, I could not find orange, but it's maybe like a yellow, right? So I'm going to say yellow, and I'm going to click, and if I scroll down, it gives me all these options of yellow. And in this case, I just want to maybe click, I don't know, plastic matte yellow might be a good option to go with. And I drag it. Okay, so I hold it down, I drag it onto it, I let go, and boom, there we go. And there we go, folks. There we have our ring, our FTC ring. Interesting stuff. So let's go ahead and make something else, and let's try, making a ring again. What I want to do is I want to revolve it instead. So Marco, walk me through how am I going to do this?
Okay, so you're going to start off making a sketch, and you are going to make you're going to get a rectangle. You're going to make the rectangle about 2 inches thick.
You sure? Or 0.57? 0.75.
No, I mean wide, 2 inches wide, excuse me. And it's going to be from the origin, it's going to be 3 inches from the origin.
I see what you're saying. So
Inner
remember,
diameter.
we're assuming you know about sketches, so we're just going to move on from sketches.
So inner diameter is going to be about 3 inches. The outer diameter is going to be about 5 inches. And then from there, you can finish sketch.
Oh, one thing though. You forgot about this side here.
Oh, you're gonna get the thickness, or you're gonna get the dimensions, and you're gonna once you get the dimensions, you're gonna put 0.75 of an inch.
Okay. Then what?
All right, and then you're gonna click finish sketch. You're gonna click the revolve.
We forgot something.
Oh, the origin.
That's right.
Yeah.
So we just realized that we forgot something, and that is, if you want to revolve anything, you have to have something that's going to revolve around. So we need to create an axis for it. So I'm going to get a line. I'll put a line through the center of the origin. This is going to act.
You can make this construction or a regular line.
That's right. So I click construction here on the left. I can also right click it and click normal/construction. So anyways, here we go. I click OK. And then we'll go ahead and revolve. So I click my profile, and it gives me the choice to click an axis, and I pick that as my axis. And boom. Now, if you notice, we made a mistake. We made another mistake. I don't know, Marco, did you catch the mistake at all?
The fillet?
Go to this, look at this. Here's our, not yet, but here is our wheel, right? Or ring, sorry. But notice, does that look the same as the other ring? It's different. What we did is that we just defined the diameter. We defined the radius, not the diameter. So essentially, it's 3 inches from this side to the other side, right? We said 3 inches was the diameter, but we just specified the radius. So I'm going to go ahead in here and click divide by 2. That's going to go from radius to from diameter to radius. So click 5 inches, divide by 2, and there we go. And then what I did is that when I edited it, when I get out of it, it's automatically going to update. So watch this. And then it automatically should change. If not, I'll be big sad. Oh, no. Oh, it's because I went back. Yes, so it's not going to change. There's my plane. There's my axis, revolve, and there we go. This looks a lot more like it. And so there's our piece. Let's go ahead and make a fillet of that. Fillet, 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 and fillet. And I'll go ahead and say 0.25 inches. There we go. And like I said, I kind of want it to look right. So I'm going to go ahead and use a yellow. Type in the word matte afterwards. And say plastic yellow. And there we go. So notice, that's 2 different ways of creating the same model. 2 different ways of creating the same thing. And so here's our 2 different sections. So I'm going to get it. I'm going to save this. So I can save this and call it, should give me an option. Save it. I'm going to call it, I don't know, we'll call it ring, right? And I'm going to go back to my playing field. So here's our playing field. And what we're going to do is that we're going to introduce what we just created. So here's our ring. And I don't know if you've been here from session 1, but we insert into current design, like the model. Oh, we should save this first. That's right. So I need to save this first. We'll call this playing field. Let's call it field. And so what I'll do is I'm going to introduce this ring into the current design. And notice when I do that, it puts it at the origin, and I want it here in the center. It's a little bit. There we go. This is looking a lot more like a playing field now. Obviously, it's a bit too high. But what I can do to fix that is I can just copy that. Once again, we'll look at the move/copy button, and we can click our part and click here this body. Oh, sorry, this body. No, it's this sketch, sorry. I can actually just click this entire ring, and I can Control-C, Control-V. If you've ever been in class before, you know what that does. So I can copy and paste this new part, right? I need to break the link first on that. Do I? Never mind, no, I don't. So
Try making it a component.
It's already a component. And so there's our two rings. And I can keep copying and pasting. So I can click that, and I can Control-Z, Control-V. Capture position, and then I can pull it. And I can just keep doing that as many times as I want. Yes, it's inefficient, but that's what you got. So that's how you make those parts. So let's go ahead and say, well, we still have some more time. I want to look at, a lot of times people run into parts they have on the robot. But if you get, for example, a Rev part, if you go to Rev and you download their extrusion set, you notice that the extrusion bar isn't entirely as to the right length because you buy a part that's 1 meter long. But obviously, if you've been in FTC before, you know that you're constricted to an 18 by 18 by 18 box. So you have to be able to shrink that extrusion down. So how do you do that? Let's go ahead and take a look at it. So let's go ahead and open up to Rev Robotics. And I'm going to head and look at a extrusion. And I'm going to look at an extrusion. I'm going to say it's a 15 millimeter, 1 meter extrusion. And I should be able to get, there it is right there. I will put this link in the chat for those who are following, in case you want access to this too. Control-C. And like I said, this is stuff that we've covered in our first session. There we go. Link is now in the chat. Now what I'm going to do is I'm going to go ahead and go to the bottom, download this. When I download this, like I said, this is a process we've done before, like in our first session. So I'm going to kind of just blaze through this. Wow, that's a lot of stuff. You don't want to see this, guys. Perfect. Now we have it there. I want to go to Fusion, and we're going to go ahead and upload this. We're going to go ahead and upload this part from our CAD tutorial. Downloads. We're going to go to CAD tutorial, and our new part we just downloaded, which is right here. I'll click upload, and it should take a few seconds for this to upload. And so it gives us a status on it, and it should be ready. But in the meantime, what we're going to do is we're going to get this 1 meter long extrusion set, and we're going to shrink it down to maybe 18 inches. And say, let's just say how that's the size of your robot, maybe. And so the way we'll do that, if you might guess, is we're going to use the press pull function. So by using the press pull, we're going to click a face, and we're just going to pull it back. So there we go. Here's our Rev extrusion. We're going to insert it into the current design. I'm going to go ahead and exit out of this. And so there it is. I'm going to maybe rotate this down so it's just for the sake of simplicity. Pull it out. Maybe look at it like this. Let's put it over here just so we can see it well. Okay. So here's our part. Now what we're going to do is that we want to be able to edit this. Now the way we can edit this is that we can actually pull this face. So, okay, my computer's having trouble again. Just a minute, here we go. And so what I do is I want to get this face here, and I want to push it back. Now 1 second, Marco, go me and
Okay. I don't know what he was doing. I forgot. But he was dealing with the extrusions. Basically, the extrusion he is currently using is using
yeah, it's a Rev
Robotics. But
so what I'm doing is I'm able to shrink this, go from 1 meter down to 18 inches. So how would I do that, Marco?
Oh, you're going to use the press pull.
Exactly.
And from there, you can push it back
Oh, wow.
to its. Oh my god.
Let me just open a new part. Let's just make this more simple. Let's just open this. There we go. Okay. Uh-huh.
All right, so you're gonna use the press pull, or you can use the extrusion, whichever.
Yeah. In this case, the press pull is more efficient. So what we do is we click this face, and then we're essentially just gonna squish it down. So here's what's really interesting, is that we want it to be 18 inches. And like I said, Fusion's kind of a smart software. What we can do is we can say, we know this is 1 meter, and we want it to be 18 inches long. What we can do is we can say 1 meter minus 18 inches. Where'd it go? Oh, it's loading again. There we go. So 1 meter minus 18 inches. Check this out. It should work. Should. And if it doesn't work, computer is loading. Okay, did that work? Oh no, I think I went. Oh, my bad. I went the wrong direction. Okay, that's really important to cover, is that I pulled it in the wrong direction. So I need to press pull this, but I want to pull it, remember, down. And what I do is I'm gonna say, how can I do that? I can say 18. Yeah, so it's negative 18. Okay, now we get a little bit of math here, but negative 18 minus 1 meter. Is that the correct way to say it? That should be it. Is that too far? Yeah, it's too far. Yeah, wowzy. No, it's 18 plus. Sorry, guys, I'm having a little bit of a brain fart here. There we go. Yeah, sorry. 18 minus 1 meter. 18 inches minus 1 meter will automatically make my 1 meter object come down to an 18-inch object. So if I click, remember, this is really important. Measure, inspect. I click inspect, look at a line, I click it, and it tells me it's 457 millimeters. That's not useful. I want to look at inches. I can go to document settings. I can click this change units. I can go to inches. And then I can go back to inspect, click a line, and it tells me it is 18 inches long. So sorry about earlier, I got a little confused in the math there, but yeah. So I can make this 1 meter long rev extrusion down to 18 inches. And now I can put this into my robot. I can put that into my field, my robot, for example, and boom, it's perfect. We're good. So if anybody has any questions on that, throw it in the chat or put on your mic, and I'm really happy to answer your questions. And so is Marco. So yeah, that's the point of that. Let's see. Any questions? Any questions at all?
No questions currently.
Okay. So what we want to do next is maybe try this out on a wobble. So let's go ahead and create a wobble. Now the way we're going to do that is open up a new design. And let's create a sketch. And we have to know this for a wobble to know our own dimensions. Well, actually, Marco, what do you think? Should we cover making wobble, or should we cover making some tools in more depth? What do you think, Marco?
The wobble wouldn't be that bad to cover.
Okay, let's go ahead and cover that then. So we have to know the dimensions of the wobble first. So we know that there's a little stick, little pole in the center, right? And we know that it's, what is it? It's 12 inches from top to bottom, I believe.
12.5.
12.5? Okay, thank you. 12.5 from top to bottom. And the thickness is 1 inch thick. The diameter is 1 inch, so it's about 1 inch thick. So there we go. That's from top to bottom. We also know that the little nub at the top is 1.3 inches in diameter, right?
Correct.
And then the height of it?
I would say about maybe
Inch.
an inch and a half.
That's a good guess. All right, so 1 inch, 1.3. And I want to have this perfectly right in the center. And like I said, this is stuff that we covered in the last session, so I'm just going to blaze through it. I'm going to get a midpoint of this, right? Midpoint of that, and they match together. Perfect. Okay. We're running out of time here, so I'll just kind of breeze through this as well. Like I said, this is going to be really, really rough. The original plan was to do everything completely dimensionally accurate, but we just had to go through it. So I'm just going to make just a sketch of, that's not right. Let's go ahead and make this a constraint. Perfect. Okay. And so what I want to do is I want to revolve. So here's our sketch of our wobble, but I need to have an axis. So I'm going to put an axis right through the center of the entire thing and go all the way up to the top. So I'm going to go ahead and click escape, click finish sketch. Like I said, guys, I'm sorry, but this is super bad, but it's because I'm running out of time. So I'm going to get a revolve function, and I'm just going to go ahead and highlight all the different profiles into the middle. So I have half of it selected for a reason, because I'm going to spin it around this single axis. So I spin it around, and there we go. Here's our really roughed up wobble. We'll make it as a component. And so click OK. And there's our kind of OK wobble. If I want to change the look of it, let's just say I want a red wobble. I can go to Appearance. And I can click, instead of bodies, I can click faces. So whatever colors I give it, it applies to a single face. Let's go ahead and try red, for example. Let's try aluminum red just for the sake of it. Let's put a red there, red up there, and red down here. We know the bottom section is black. Let's go ahead and type in black. So let's go ahead and pick something random. Let's try paint enamel glossy black. Put that on the bottom. And so this, like I said, it's very rough. I'm running out of time. But here's the idea. You make a sketch, you find a profile, and you revolve it. So you revolve your profile around a certain axis. And then
You should make it a different material.
That's right. Thank you. Physical material. And like I said, I can change what it's actually made out of. So I think it's actually made out of plastic, and I'm assuming ABS. This is my assumption. My assumption is ABS, but I want to apply it to the entire thing. So I'll say ABS for the entire thing. And now, there we go. So it's still the same color, but what it's actually made of is different. And this is useful when you get to more advanced stuff. So if you want to run a simulation on this, for example, let's just say you want to run how much weight it can handle before it snaps, you'd have to know what kind of material it's made out of. And that's really important for this here. So yeah, questions? Any questions at all? If so, throw them in the chat. I'm really happy to answer. Marco, do you have anything to add to this? Anything I missed out on?
Oh, coil, if you want to try the coil.
That's right. Okay, so what I can do is cover a coil. If you go down here, this is a coil. Where to go? Coil right here. And I can. This is super easy in Fusion. I can make a sketch right here. Pull it out. And what's going on? Hold on, what am I missing out on? Is this right?
I think it's just taking time to load.
Hold on. How good of a computer would you need to run with these simulations? Oh, thank you for mentioning this. Okay, you can run really advanced simulations and you don't even need to use your computer CPU at all. You have two options. You can run your simulations on your computer, which the question, yes, would be how good is your computer? Honestly, it's the better computer is the faster your simulations. But you can send your simulations to Fusion's computers. Remember I said Fusion is a cloud-based software. So you can send all of your simulations, generative designs, your renders, all the heavy-duty processing, you can send it to Fusion's processors in their servers. And you can do that and they will process it for you and they'll send it to you. And of course, it's wildly faster than what your computer can do, but it costs money. But here's the deal though, here's the trick. As a student, you have access to free cloud credits, essentially free money. So you can run simulations, renders, designs, all for free. Well, other people have to pay for them. So I highly recommend you go ahead and use those. You have access to Fusion's highly powerful servers and processors, and you can use them for free. So does that answer your question, Nicholas? Let's see. All right, perfect. Any other questions?
Hey, Lucas, I got a question for you. When you're talking about those simulations, how much, I mean, is it like one simulation to one credit, or is it just kind of an unlimited thing for students, or how does that work?
Okay, well, for generative design, you have unlimited. Okay, well, you have unlimited cloud credits as a student. However, you're limited to 16 per job, right? So like a lot of things like renders, if you want to have like a super high quality render, you're kind of limited, right? For simulations, normally you're not limited. For generative designs though, you have unlimited access, like unlimited. You can spend thousands of credits on that. You'll be totally fine. And like I said, one credit is $1, and you can spend you have unlimited. One render would be about, for me, I can pull it off with about maybe 12 cloud credits. I can do a simulation for maybe like 8 or something. Generative designs, those are 25 cloud credits to run the simulation, and it's 100 to download it. So I'm technically spending $125 per simulation, but I'm doing it completely for free. So yeah.
Oh.
Yeah.
All right. Any other questions from anybody that's attending? All right. Well, Lucas and Marcos, or Marco, I do appreciate you guys. I mean, I have learned so much on Fusion 360. I do greatly appreciate it. It's got a lot deeper than I was expecting, and there's a lot of great information there. So, just to wrap up, do you have any kind of previews for your upcoming robot for the ultimate goal?
I'm not exactly, I do have something very detailed stuff carried out, but I don't know if I'm willing to share that just yet.
Okay.
I will say that I do have some renders that I've done using Fusion's rendering. Let's go ahead and not get, oh, this is blowing all of my information here. Let's go ahead and go to pictures here. And we'll go ahead and go to renders, and we'll go ahead and go to logos, and we'll go ahead.
See if we can get a little sneak peek on something, even if it's just a.
Yeah, so these are some of the renders I've done
There
with
you
Fusion's.
That's cool.
These are just random things I've done. This is just experimentation. Like I said, you can get these for free, and you can get some. This is all in 4K. These images. Yeah.
I can tell you one thing. Can you guys hear me fine?
Yeah, go ahead, Coach.
Yes.
I've been seeing some of the stuff that they're doing because I know they're working from home a lot, and I'm pretty impressed so far with the work that Xenon is doing. They're probably going to do like a teaser, maybe within a month or so. The robot is pretty complex, but expect something pretty big from them because it looks really, really good. They're still in production, but we'll go ahead and do a teaser trailer, and we'll let you know whenever they're ready to show some of the work that they've been doing. But they've been working hard at it, and so far the results have been great.
Sounds good, Coach. I appreciate that. And for those that are watching us and joining us today, please don't forget that here in the RGV we've launched the Power Up challenges. Please take a look at those on our website. You can find those quickly at firstrgv.me/up. Look at those as some opportunities for you all to earn some extra money for your team, for parts and supplies and whatever else that your coach needs to help you be successful this season. So with that, I'd like to just thank again the amazing Patriot Engineering program with Mission CISD and their great students. And with that, I'm going to close out and say, hope everyone has a great weekend, and we'll see you soon.
Thank you very much.
Laters.
All right, that's it, guys. It's running the outro now on the internet. So thank you, guys. And are y'all going to be the ones working on that Vuforia project, or is that going to be a different group? Okay. All right. Well, Lucas and Marco, y'all have a great weekend. Coach, thanks again for stepping up and helping me get this information out to the teams. And best of luck. We'll see you soon. Yes, sir. All right. Y'all take care.